So one of the things I love on this, about the city is there's a lot of internationals here. There's a lot of, companies being founded here. And one of the reasons we started AI Monday also in Berlin, in Germany, was that 65% of the startups in the AI scene in Germany are actually located in Berlin. And so I think Berlin Partners also doing a great job in kind of marketing this fact and getting companies and corporates here. One of those startups that has been founded in Berlin is Deep Neuron Lab, which Andreas Schindler, who is now coming to the stage, is one of the co-founders. I think the whole team is here. Maybe raise your hands. And so happy to have you here. Not just today. I think you've been also joining some of the AI Mondays in the past a lot. And then Andreas and his team actually got a prize just recently, the Gründerpreis from the BMWI. So congratulations on this one. Yeah, so big applause to Andreas, and thanks for coming.
Ich glaube, ich brauche es nicht, oder?
And I switch your presentation.
Okay. I can't believe there's so many Berliners in here, 2/3. Every time I go to a party, I'm really from Berlin, and I tell people I'm from Berlin, they're like, "You from Berlin?" It's like, where else would you meet Berliners? Okay, super hard to follow up on such an interesting and powerful talk, but I'll do my best. Deep Neuron Lab, we're a startup here from Berlin, founded last year. We're a machine learning agency. We build tailored solutions for our customers. Our customers are insurance companies, banks, rating agencies, and we've kind of specialized on PDF as a format to work with. But enough advertising, let's go into the talk. You'll find more about us during the talk. I will present some of our business cases we've solved or not solved. And as the name announced, it's the good, the bad, and the ugly. I will have 3 business cases here. And I choose this title because, well, it sounds cool, and I like the movie, but also because of the 3 cases I will present. But if you take one thing with you from this talk, it's that you should always do a feasibility study before starting a machine learning project. No matter if you do it in your own company or do it for another company, because we believe that in the first 10 days, 5 to 10 days of a project, especially a machine learning project, you can find out all the information you need to know if a project will succeed or not. Let's go into the business cases. The first one, the good one. The good one looked bad at the beginning, but turned out good for us. Our customer here was an insurance company, and what they wanted was an image classification. They used an online platform for their customers. It was a travel insurance, so if you get sick shortly before you're traveling, you can get your money back. And they had an online platform where their customers, in case of they want to get their money back, they just sign up in this form, upload some documents, and the process is automated, halfly automated there. Because when the customer uploads their documents, for example, the sick notice looks like that. It's an Arbeitsunfähigkeitsbescheinigung in German, or AU. The AU, if you upload that, the insurance company still has to check the uploaded documents if you really uploaded the Arbeitsunfähigkeitsbescheinigung, because you could have uploaded a selfie. So what they wanted was an image classification, fairly easy use case in machine learning, where we take the images they had uploaded on the platform and classify them in Arbeitsunfähigkeitsbescheinigung and not AU. The challenge here was, shortly before we started the project, before we started the feasibility study, they told us, we can't give you the data, because actually our customers didn't give us the allowance to share the data with third parties. So we were starting off a machine learning project without data, which, if you've worked in machine learning, is a bad point to start off. But we think of ourselves as data scientists, and somehow this is combined with solving problems. And we found a solution to that problem. It was data do-it-yourself. We generated the data ourselves. How did we do it? We went to the doctor and got sick notices. And we got a bunch of those. One of our founders, the one you see up here, Jason, also had a few lying around at home. We started taking photos of them, copying them in different ways, putting them through a fax, because in Germany faxes are still a thing. And we generated about 30 images with that. And then we used a library called image augmentation and augmented another 11,000 images with that. Used that and built a classifier that worked pretty well. The customer was super happy, and we took a bad case to a good one. Talking about that one, the bad case. That one actually looked good in the beginning, but turned out to be really bad. Also an insurance company, and they wanted a machine learning supported input management. Meaning in their loss department, it's a special kind of insurance, credit insurance, and there's lawyers sitting in the loss department, so really high-paid employees, and they were spending half of their day sorting documents. The customer were sending them documents, different kind of documents, and what they were doing half the day was sorting those documents in their loss system into different folders. So putting the contract into the contract folder and images into the images folder, and they were not happy doing that. So pretty good case for machine learning. What they wanted us to build was an input management system where we classify the input document and put it into a according folder, and then give the employee a list of the documents that are still missing, so they could send this list to the customer and tell them, hey, I'm still missing some documents here. Or if all the documents were there, they could start working on the case. They told us they have about 60,000 cases, historic cases we could work on, so we thought like, yay, data. And we asked them, was the sorting task easy? Like, could you explain it to a intern in half an hour, and could they do it? And they were like, yeah, it's super easy. Everyone could do it. And then we started our feasibility study. We always do that before telling a customer that we will do a project. We'll do a feasibility study where we spend 10 days with the data and check the data. What we found out was that the data was inconsistent, meaning we found one kind of document in different folders, so classified differently. And we banged our heads against the laptop, but we couldn't figure out why this same kind of document was in different folders. So we did a telephone conference with a customer. There were 2 employees in there. They were lawyers. And when we asked them the question, they started fighting about where to put this kind of document. We found out during this phone call that actually every employee uses this folder system they have individually, meaning all our historic data is not worth nothing. That was the moment where our inner Gandalf told us to back off, and we were like, peace out, this is not a project we can solve, because there's no business case. We saw ourselves sitting there 6 months sorting data and cleaning up the 60,000 cases they had in there. This was a case where, after the feasibility study, we told the customer that this is not a case for machine learning, or it is not yet a case for machine learning. Because we told them that they should start using the folder system they correctly implemented, to start using it correctly, and maybe in 18 months we would have enough data to start a project. The customer was actually pretty happy that we did not sell them a big project up front and then told them 6 months into the project that this would not work, and they're still a good customer for us with our other projects. The ugly one. The ugly project also started good and turned out really ugly. our customer, also an insurance company, we also work with other companies, but I don't know why the case are all insurance companies. They wanted an intelligent contract management system. They wanted us to extract information out of their existing contracts. They have one special kind of insurance policy where every contract is kind of individual. So the loss adjuster does not, or the underwriter, they don't know upfront by the tariff what kind of, how much deductible is in the contract, and they don't know the details. So they have to check the contract every time because every contract could be individually. The problem for the insurance company here was that they stored the contracts as PDFs and as image PDFs, meaning that the employee would have to read 40 pages every time they just try to find out what the deductible was. So what they wanted from us was a system based on machine learning that reads through the documents, extracts the contract relevant information and puts it into a database. So they could put a front end on this database, and the underwriter and loss adjusters would just work with this front end and see how much the deductible is on every time on the same page to make their life easier. And yeah, we had training data there. It was fairly clean. We started out with our feasibility study again and came up with some challenges. The first one was incomplete training data. They gave us a database we were supposed to fill. The elements in the database were not all included in the contracts. We found that out again during the feasibility study. We always try, it's a heuristic of how we work. We always try to do manually what the AI is supposed to do, and if we can't do it, then it's probably pretty fair to say that we cannot build an AI to do it, or it's going to be really, really hard. We tried it out, and we couldn't fill out all the fields within the database. We talked to the customer, and they told us, well, it's logical. If X is in the contract, then Y is automatically insured as well. Well, yeah, you know that, but it's not in the contract. So any system that is supposed to extract the information out of the PDFs can't do that. That was the first issue we had, or challenge we had there. The second one was explainability. When working with machine learning, we work with probabilities, but sometimes a customer is not happy with knowing that 95% or 98% of their contracts are correctly transferred into the database. They want to know which 2% or 5% were not transferred correctly. Yeah, so the customer here had a high demand for explainability. Second challenge. Our solution was we used machine learning just for the OCR and for classifying different paragraphs, and then we used fairly simple techniques like regex to extract information, which helped us to really know what happened there and get a good grasp of what happened. We filled those missing pieces in the database with handcrafted rules. And this is where this project turned ugly, because we started with writing handcrafted rules to fill the database, and then we continued writing handcrafted rules for the database, and we continued writing handcrafted rules for the database, and we continued writing. There was a lot of handcrafted rules in the end, so it was, it felt like we did all the work by ourselves and the AI didn't do anything. But the customer was happy in the end, so all for the customer. In conclusion, why you should do always a feasibility study before starting a project, because you need information. You don't have all the information up front and you can't just start. There are questions you need to answer up front. For us, we have questions in 3 dimensions we try to answer within the feasibility study. First dimension is data. Do we have enough training data? Super easy question to answer. But is the training data labeled correctly? I explained before why this can be a problem if the training data is not labeled correctly. Also, enough training data. Can you get to the training data? Okay, can you get the training data? Sometimes companies have the training data. They have the training data even labeled, but they just can't extract it out of their systems without losing the labels, for example. We had that in one case. So first dimension is data. Second one, users. Very important question, how much explainability does your user need? Are they happy with knowing that 98% is correct, but not knowing what the 2% are? Do they need to know when your system fails or when it works? And secondly, how will the user use it? We love working with algorithms and tweak them, improve them, but we had in one project where we forgot that the user, the end user, cannot use an algorithm. So don't forget to think about how to implement that into a workflow or into a UI. Sometimes this takes even more effort than building the machine learning algorithm. And the business case. It's important that you also have a business case. First question we answer here is, what are the expectations? In our experience, most customers have higher expectations of AI than are technically possible. So always what's part of our feasibility study is doing a AI workshop with all the stakeholders and informing them about what is the state of AI, what is possible, what is impossible right now. And then what impact will the solution have? If you're, for example, automating a process, it does not make sense to automate a process that costs the company 10,000 euro and spend 100,000 euro if this 10,000 euros not done 12 times per year. So we answer all those questions in the feasibility study, and in my opinion, if you haven't answered those, you cannot say if a ML project, machine learning project, will be successful or not. The great thing is you can answer those questions really, really quick in 5 to 10 days or even quicker. So why should you do always a feasibility study? Because before you answer those questions, you know nothing, and without knowing, you cannot make your customer happy. I'm not here alone today. I'm here with my co-founders, so if you have any questions afterwards, you can also ask them. Please raise your hand, guys. There, Julian as well. He's our new data scientist. We launched a website recently, redactify.de. It's one of our use cases we've solved. If you're having trouble with redacting documents in German, it's still in German language, we have found a way to automate it with machine learning. Thank you for your attention.
Thanks so much. Any questions?
Thank you for the presentation. Just a quick one on the first, sorry.
Yeah.
Thank you for the presentation. On the first customer that you had, do you have any visibility as how to the model performed? And if it, how does it fall in line with the, fraudulent behavior, such as what our colleague was talking about earlier? But in general, like how did it perform after you've released it to the customer?
Okay.
The AU.
Yeah, the AU case. The AU case, because of time issue, I actually did not explain the whole case. What we actually did here to start off was we helped the customer give us more data, because based on the 11,000 images, we couldn't build a feasible classifier. So what we did is we used those 11,000 images. If I go back to the images, you can see that the information on the image, on the AU, is in a certain part of the image. So what we did is we built a tool that anonymizes this part, that blurs this part. And that was working pretty well. Wait. Okay, whatever. So that was working pretty well. I think we had about 98% point something accuracy there. But we didn't care about the 1 point something percent, because the box was blurring of the relevant information we had there. And afterwards, the classification algorithm worked even better. We were in 99 point something there. Yeah.
Another question? Well, you guys think how much project requests you get end up in a ML project afterwards, after you've done your feasibility analysis, and how much turn out to be something different or turn out to be not happening at all?
Most of them happen. We actually just had one case where we kind of declined the case, because when doing the initial workshop, we scout for problems that sound at least like machine learning solvable problems, and sometimes customers have other expectations of what is solvable with machine learning, but we filter very hard up front. But sometimes getting the data gets the information then, and then it gets, I don't know, it's like 10% or.
Still quite a lot, I think. Yes.
Hello. So thanks for the talk. And my question is regarding sometimes the customers are really reluctant to share their data. So if you come across such a case where you don't have data, customer doesn't want to share the data with you, so how would you deal with it? You just straight away say, no, we cannot do it, or you have some other ways to figure out a solution for that scenario?
How was the question? How do we clean the data, or?
Not the clean. Like if customer doesn't share the data with you.
Yeah. Okay. So we don't get the data.
Yeah.
Yeah. As I explained, the one case before, sometimes you can generate the data yourself. If you don't have such a case, which cases are out there where you can't generate the data yourself, you can help the customer to be able to give you the data. For example, build them something that anonymizes the data, gets the data, so they don't have, the biggest issue is data privacy. That's why they don't share the data. If they don't share the data out of any other reason, I doubt that they want to do a machine learning project. But if they don't share the data because of data privacy, it's a logical reason. People are afraid of that. But there are systems out there. There's other startups like Status in Berlin that if you have structured data, they help you anonymize the data but keeping the statistical properties of the data. What we did, we helped the customer anonymize the images, blur out all the personal information. So there's different workarounds to help the customer there. But you have to find out if it's just if it's the real reason or just something they say because they don't want to do the project. Yeah.
Thanks for the great talk. I was curious. I've made a lot of prototypes, and the prototype works really well, and then you give it to the team that wanted the prototype. And then they're like, we'll get around to actually using it, but we've got other things that are more important right now. Yeah. And so has that ever happened to you? And do you filter customers to see if it's actually going to have an impact, or do you just say as long as they're happy with the prototype, we're happy too?
Well, we're not happy too if they just want the prototype, but that definitely happens, especially in bigger corporations. When you get to implementing the algorithm, you have to talk to the IT. And in German financial institutions like insurance companies or banks, the IT is planned out for the next 2 years. And if you bang on their doors and ask, hey, do you have capacity to implement this cool machine learning thing? They're like, yeah, in 2024 or something. Definitely, really, really long implementation cycles, and that's why we try to get to a working prototype really, really fast, because it's easier to talk to the IT if you have something that is working, if you have proven that it has a benefit, a real-life business benefit also, and yeah, but it's a problem that's out there. Yeah.
Thank you.
Thanks so much, Andreas. Big applause.